Hello, this is Kimitsu, and this is a short video response on Etho's quote challenging problem unquote. The problem is, if we have our storage variables based on hoppers, like he does in his pet project, there is a question how to make the output of each of these variables affect another variable in a proportional way. So to do that, we need a signal strength to length converter. So placing a comparator like this, we can output a signal strength based on the amount of items in the hopper, and this is a simple signal strength memory cell, but it would be so if it was like this. But we have another piece of wire here which makes this memory cell to slowly decay like this, and the amount of time it takes for it to decay is based on the initial signal strength. So if we, for example, have like one stack of redstone here, this thing will decay almost instantly. We can use that to affect other variables like this. So for example, we have a variable here. Let's test it now. So we have all 5 stacks here. Quickly power cycle the piston. It took out 8 pieces of redstone dust. Let's see what would happen if we have like half of this amount. Not like that. Yeah, like that. It took out 4, so we see that it works pretty well. Well, one thing these two comparators turn off too quickly. It just can take out just a few items before the signal expires. So if we want to make it longer, we might want to use a whole line of these things. So this will take like 1, 2, 3, 4, 5 times more, supposedly. Let's test it out. Let's fill this. Okay. Here's our variable. Activate. As you can see, it slowly depowers, and it takes much longer. Okay, 28. So 64 minus 28 is 36, I guess. 36. Does that make sense? Yeah, I think it does. Well, it's not exactly 8 by 5, but you get the point. And if we have a few variables, some of them might affect our output variable in one way, some might affect it in another way. We have to just activate these pistons one after another. We have to wait until the signal expires before activating the next piston, and that way we can actually perform a set of arithmetic operations on our output variable. There is a few things to consider, like how long should it take for each piston to activate and stuff like that, but this challenge is not so hard, I guess. Well, also these lines of comparators are somewhat slow and might kinda lag and not very flexible, because the more of those you add, the longer you have to power this piston for. Well, because otherwise they will start blinking in an unpleasant way. To somewhat solve some of the problems, you could use this contraption. It's a little bit bigger, but it's more flexible. So it only has two comparators to store the signal strength, but it actually has one of them in subtraction mode, and it is connected to another comparator which is almost connected to an item hopper with only one piece of redstone dust. But it's not quite connected yet. Now if we put some signal strength inside of this memory cell, this torch will depower, no matter what the strength is, and it will actually allow this clock to tick, and upon ticking this clock will this clock will activate this piston for short period of time after each tick, and that short period of time is just enough to subtract one value of signal strength from this thing. So let's see how it works. So this clock ticks, and each time it just takes one. What that means is we can modify this clock for any kind of delay, and this will provide very slow decrease of this signal strength. So we can use that too. Also, this way of doing is eliminates the problem with activating this initial piston for a short period of time, for long period of time rather, because we only have two comparators here, and that means we need to activate this input piston for just like one tick. So that is it. That's the basic idea. I hope, if not Etho, someone will find it useful for some of their stuff. So good luck with your redstone projects. See you again.